Hey chemistry, still smoky. So now we're going to talk about cohesion and adhesion. So cohesion is the attraction between like molecules. So for instance, water is strongly attracted to other water molecules through this hydrogen bonding. So we would say that water has high cohesion because it's attracted to itself, to other water molecules. In fact, water has such strong cohesion that you can actually see situations in which water droplets will refuse to sink into the water because they're so attracted to themselves within the droplet. And so they're able to bead up and basically kind of float around on the surface until at some point they will sink back in and join the rest of the water. That's why you see droplets that are able to maintain their shape um, like this instead of just kind of spreading out and flattening out. They're able to maintain that nearly spherical shape against the force of gravity because of that strong cohesive force. Cohesion is basically related to the surface tension because they are basically attracted to each other very tightly. So again, cohesion is the attraction between like molecules. Here's another example. So mercury has very high cohesion. Mercury is able to stick together with other mercury atoms very tightly. And what's kind of interesting about mercury is that it is far more attracted to itself than it is to other substances like glass. So it doesn't do what we call wetted. It doesn't coat the surface, but rather flows over the surface. Rather than sticking to the other substances, it is much more focused on sticking to itself, so it will roll without sticking to other substances. So that is strong cohesion. Adhesion is the attraction between dissimilar molecules or other molecules. So water, although it has strong cohesion, also tends to have strong adhesion, meaning that it has a tendency to stick to other substances. And so, for instance, if you look here at these water droplets that are hanging off the pine tree here, they have strong adhesion. They're sticking to the pine needles, and they are not falling against the force of gravity because they have more attraction to the pine needles than the force of gravity has pulling it downward. So they have strong cohesion to stick together to form a droplet to begin with, and they have strong adhesion that they can stick to those pine needles. Water also is sticking to this spider web here, so they're not just falling right off of the spider web, but rather they're able to stick on and stay there until they evaporate. You'll probably notice that water has strong adhesion to glass, which is one reason why if you try to wash a glass out, it doesn't dry out very rapidly, but rather it just kind of stays wet, and you're going to have to like take a towel to kind of wipe it out or wait till it evaporates. Adhesion is used by adhesives, such as tape, which use intermolecular forces to stick to the surfaces of things that they're placed on. So on the underside of tape, the sticky side of the tape, has all of these dangling little molecules whose design is to stick using van der Waals forces, whether they be dispersion forces or dipole-dipole forces, but to stick to the surfaces of the things that they're placed on. Because they are not like little claws that dig in, they're not a glue that forms a chemical binding, but rather they're just intermolecular forces. Tape can be peeled on and off of the surfaces over and over. All you have to do is apply a force greater than the force of adhesion, those intermolecular forces, to be able to peel it right off. Now you'll notice that you can do that with a piece of tape over and over and over, and it will basically keep sticking and keep coming off. But eventually it starts to wear off, and you're not able to do that any longer. That typically is because it is particles of things like dust and little paint chips and whatever, skin flakes, whatever it is, start accumulating on the underside, and no longer are those molecules in contact with the surface you want, but rather they're in contact with the dust and other particles that are collecting there. So they lose their stickiness simply because the intermolecular forces are still there. It's just there's stuff in between that's preventing them from getting in contact with the surface. You'll also notice things like geckos use adhesion to stick to the surface of glass and walls as they climb. So we talked a little bit about geckos before. All they need to be able to do is have enough force to overcome the force of gravity that's going to pull them downward, yet not be too strong that their muscles can't overcome it so they can lift their feet up and place them back on. All right, so adhesion and cohesion results in a phenomenon known as a meniscus. So anytime you like pour water into a graduated cylinder or a test tube or something like that, you're going to notice this kind of curved surface here of the liquid. And that is due to adhesion and cohesion. So essentially what's happening here is that the water molecules are strongly attracted to the glass because glass is polar and water is polar. So the water molecules are sticking to the glass, and then the water molecules are also sticking to each other due to cohesion. And so it can kind of create this kind of climbing effect where basically the water molecules are sticking to the glass and then they're kind of pulling other water molecules up behind them through the cohesive forces. Because of this, it can be difficult to determine exactly what is in there. The rule of thumb with measuring water is you read from the bottom of the meniscus. So you try to set up your eye level. So you try to have your eye, this is going to be an evil looking eye, and kind of like a cat eye. You're going to have your eyes looking at the bottom of the meniscus when trying to measure the volume of a liquid. Now, you can have meniscuses that are, or menisci, that are either concave, which means they curve downward, or convex, in which they curve upward. So for instance, water forms a concave meniscus, while mercury forms a convex meniscus. The reason for that is that water has strong cohesion, as does mercury, so both of them tend to stick to their own molecules really tightly. But water also has strong adhesive forces that stick to glass, and mercury has very low adhesive forces. Mercury does not stick to glass. So mercury will kind of dome up because they're not interested in sticking to the glass, and they're going to try to reduce the surface area that they can with the glass and increase the surface area they can with each other. Water, on the other hand, is attracted to the glass, and so will have a tendency to kind of rise up the side of the glass. Okay, so if I have you in class, we're going to do this coin challenge. But if not, I want you to try this at home and email me your results. I want you to take a penny, and I want you to find a dropper somehow, and I want you to try to see how many drops of water can you get on the surface of a penny before it spreads out and spills over the edge. And I have seen a variety of numbers, and I don't want to tell you what the highest number I've ever seen at this time, but I have been impressed. The water is going to basically form this dome on the surface of the penny due to that strong cohesive force and that strong surface tension. And it can overcome the force of gravity that should have it spill over the edge and start going all over the table for quite a bit before it eventually does. All right, so just to clarify our definitions, cohesion is what allows water droplets to stay together because it is the attraction of like molecules. The surface tension is what allows them to bead up and form a dome against the force of gravity. And adhesion is what allows them to stick to other molecules, so dissimilar molecules, which allows these water droplets to attach to the leaves without just running off and down to the ground.